Hello everyone, myself Puneet Singh Chandel. Today I am presenting NAT 3 as internal question paper. First of all, this is questions of all. First question is write an algorithm to solve a simultaneous linear algebraic equation using Gaussian elimination method. So first of start, then input the number of equation and take input of n and input the assign matrix size of and in taking uh, multi-dimensional array input, forward elimination. We apply loop from k to n minus 1, then another loop from k plus I is equal to k plus 1 to n, and compute the factor of f is equal to a of I of k by k of k. For another applying another loop j from k to n plus 1. For another another calculating fi and j of I. So back substitution, we doing the back substitution in there. Uh, uh, we doing back substitution in there. X of n is equal to I of n, and this for and applying another loop from n minus 1 to down to 1, and sum is and initialize this sum is equal to, and applying another loop for for j is equal to I plus 1 to n, and sum is adding fi of j plus x of j, and x of y is equal to a plus I of j plus s minus the sum and a plus I of j, and output the value of this and end of algorithm. My second question is explaining pivoting in solving simultaneous linear algebraic equation and why it is needed. In solving simultaneous linear equation of pivoting means rearranging the rows of the acyclic matrix to make the sure the pivotal element in a non-zero and preferential arrangement. Why it is needed? Avoid the illusion by the zero. Improve the accuracy. If the pivotal is too small, it can be lead to the round off error in the pivoting point arithmetic. Ensure proper elimination type of pivoting, partial pivoting, computer pivoting. And the third question is explain the what if condition simultaneous linear algebra equation and the how to solve them by referencing Gaussian elimination method. And in a condition system of linear equation is where of on a small change in the data cause the larger range in the solution. Refining Gaussian elimination. Use the partial pivoting and camp routes to bring the layer of absolute pivotal element to the diagonal. This improve the numerical stability. Second is scaling. Scale the rows so to that the all coefficients are roughly the same. Improvement. After the computing on the approximate and cheat of if a of x is equal to b is not calculate the resident h is equal to b minus of a minus of x. Solve this for the correction of a or x. Update the solution or action new is x plus delta of x. Repeat if you need. The fourth question is write an algorithm to solve simultaneous linear algebraic equation using Gaussian iterative method. Algorithm start input the number of equation of a coefficient of matrix of n right side of vector b of n tolerance. set iteration is equal to 0. Repeat until iteration is less than n. Loop I is equal to n minus 1. I is set a sum of 0. For of j is equal to n minus sum of sum plus I of this, and set the near this. Update x of y is equal to and dot x of y, set the iteration is equal to iteration plus 1. Print this final vector x and stop. The fifth question is compare Gaussian elimination method with the Gaussian serial iterative method and explain how to select the appropriate method to solve the simultaneous linear algebra equation. The feature, this is the differentiation for Gaussian simultaneous method and Gaussian serial method. Type: direct method, indirect method. Approaches: soft outcome in the ear approach, and this speed uh, faster to that, and it is slower that. Accuracy: it is more accurate, it is not, it's less accurate. Memory: high memory use, less memory use. Printing: yes or no. Okay, this is end of the third internal assignment paper. Thank you.